Appreciate that introduction. Let's let everybody come on here. So let's see, just double checking. Kay, Alyssa, Andrew, perfect. It's my pleasure to introduce a portion of the team that is responsible for this year's Trusted CI Annual Challenge. The focus of our annual challenge this year, every year, Trusted CI has kind of a focused activity that it spends a year dedicated to. Last year, there was a focus on trustworthy data with a team led by Jim Basney. This year, we are focused on the assurance or security of software that's developed and used in scientific cyber infrastructure. So today, we would like to report out to you a bit about our initial findings and also some of the draft set of solutions that we're putting together in a guide to be distributed later this year. I would like to introduce the panel. Hopefully everybody can see this slide now, which includes Kay Avila and Andrew Adams and Alyssa Heyman. Kay Avila is a senior security engineer at the National Center for Supercomputing Applications at the University of Illinois. She's been a member of Trusted CI since 2017, and her role includes operational network security responsibilities for the Rubin Observatory and also managing the Zeek IDS at NCSA. Andrew Adams is the Principal Information Security Officer at Pittsburgh Supercomputer Center. His primary role is security manager of the Bridges 2 supercomputer, and he is also the CISO for Trusted CI, where he's been a member since 2015. Alyssa Heyman is a senior scientist on the NSF Cybersecurity Center of Excellence at University of Wisconsin-Madison, and an associate professor at the Autonomous University of Barcelona, where she coordinates vulnerability assessments for Trusted CI. And her work is supported by NSF, the Spanish government, the European Commission, and NATO. And lastly, I'll just introduce myself. My name is Sean Peisert. I'm a staff scientist at the Berkeley Lab and an adjunct professor at UC Davis, and I'm one of the co-PIs of Trusted CI, where I've been since 2019. I'd also like to shout out to the rest of the members of the annual challenge team who participated in the software assurance study, which include Mark Krentz at Indiana University, Jason Lee, my colleague at the Berkeley Lab, the NERSC supercomputer facility, and Barton Miller, also at University of Wisconsin-Madison. And finally, I'd like to thank a number of the members of the community, the scientific projects that contributed insight and information into this study as well, which is the Fabric project, the Galaxy project, the High Performance SSH SCP project, Open On Demand by the Ohio Supercomputer Center, Rolling Deck to Repository software project, and the Rubin Observatory. So with that, I will lead us into our panel for today. Our panel includes a number of questions that I will ask of the panelists. It will also include questions for you, the audience. So although I do actually encourage you to type in your own questions, I do have some specific questions for you as well. And so please keep eyes open for that as well. And by the way, I'm assuming that someone is spotlighting the panel. And if that's not happened, if somebody could do that, please, that would be great. So I'd like to begin with the question to the panel. Security is always a mixed bag, right? Sometimes we learn things that we wish we were doing better. Sometimes we find great things that we're doing, and we want to shout those out so that way the rest of the community can learn from them. So my first question to the panel, which I'll ask Andrew to start with, is what were some of the most interesting things that you learned software projects are in science are doing well?
Thanks, Sean. Yeah, so I was pleasantly surprised to see that most of the projects we interviewed were actively applying conservatism in what permissions their systems granted to users. It's possible they might not have been aware that they had adopted Salzer and Schroeder's least privilege principle, but it was reassuring to see the developers' choices in any event. Also, and I'm not trying to be funny here, but the fact that none of the projects we interviewed were trying to roll their own cryptography is a very good thing. Crypto is hard. It takes a significant amount of peer review before it can be trusted. So again, good news in that this message seems to be getting through to the developers.
Thanks so much, Andrew. Alyssa, let me toss it to you next. You spent a lot of time looking at some of your areas of interest in training and tools and testing.
Yeah, Sean, before talking about those specific areas, I was very impressed by the willingness of the different groups to spend time with us, the Trusted CI team, and to be open and honest about their projects. And it was, instead of saying, oh, we are good, just get away from us, it was like, look, this is what we are doing, help us to do better. So that was kind of the first big surprise, and that was great. And now down to my more specific areas. We were talking about tools that the project use, and we were concerned about tools, dependency checking tools. I mean, tools for checking the problems that happened in the software stack the projects were using, and automated assessment tools, that is a tool for finding vulnerabilities in their code. And some projects were using dependency checking tools, and also there are some like fine tuning to do there, but it was good to see that projects were using those tools. As for automated assessment tools, let's say there's more progress to be done here. And I'll mention now a bit about testing. And we saw that almost every group was doing unit testing. But as it wasn't surprising that more unit testing was done than end-to-end testing. And also the testing was focused more on functionality rather on security. And I can talk later about training.
Thanks so much, Alyssa. That's a lot of good stuff. Thank you for sharing that. I think as we will demonstrate in our guide, there are a number of great practices related to testing and dependency checking and other things that aren't very hard to do, and it's great to see that some in the community are already adopting a number of those practices. Kay, you had some thoughts on some of the good things coming out of the software development community as well.
So speaking from more of a management process and code storage side of the house, one of the good things we saw was that all of the projects we spoke with were using some sort of code repository and version control, although to what extent they were using it and to what features certainly varied by project. Some of them were using more extensive use of branches versus no branches and everything in between. And they all happened to be Git based, which was interesting. That's not necessarily a positive or a negative, just an observation. But the reason, aside from it being a general good practice to use something like that, is because it has the underlying dependency for managing security updates. Is having that version control allows us to do these different releases and more clearly convey the changes that are being made, as well as having that history of what's been changed in the code and who's doing the changing. The other nice thing we saw was that all the projects were using some sort of issue tracking software, whether that was a ticketing system like Jira or RT or the issue tracker within GitHub. So that was promising too.
Thanks so much, Kay. That's great. So I have my question for the audience then are, what are some of the things that you think that in your observation that the scientific software development community is doing well? And that could be your own team or some of the other sorts of things that you've observed that other developers are doing that we haven't covered here. We've heard about conservatism, software developers already being cognizant that about the principle of least privilege, even if they haven't read Salzer and Schroeder, not trying to create your own cryptography algorithms, use of dependency checking tools and automated assessment tools, use of code repositories, branching, version control, this sort of thing. What are some of the other things that software development teams are doing particularly well? I'm actually going to toss out one myself, which is that I see a lot of software development tools writing in languages like Python. Certainly this isn't universal, but you write in some higher level languages that are type and memory safe, and you're certainly automatically get rid of certain classes of bugs related to the improper use of pointers and memory and so on. And so hopefully we'll see an acceleration of that going forward as well. Certainly you can't use Python for everything for performance or system level issues, but who knows, maybe we'll see more in the way of things like Rust in the future and to take over from traditional C, C++ sorts of languages. I'm going to leave this question on the table in terms of other things that you think software projects are doing well for security. Please feel free to put questions into the chat. But at the same time, I'm also going to move on to the next set of questions for the panel. Panel, I'm going to choose a different order now. I've opened chat to participants. Yes, please, or just the Q&A, either way. The next question to the panel is, what were some of the things that you think software projects should focus on doing better? And let me actually kick this off in backward order and start with Kay, if we could, please.
Although I mentioned that all the projects were using Git-based version control, only a few of them had separate branches or releases for security issues, and that's an area that could be improved. The issue being that if security issues are combined with feature releases, that stops users of that code from might be dependent on a particular version, can't upgrade, or may choose not to upgrade because they don't need new features. That stops them from being able to get security fixes, which is obviously a concern. Also,
okay, can I just stop you right there 1 second? Is it, in your life, in the real world, where are the kinds of places where you see this come up most often? And I guess in my world, I see this maybe a bit on some of the Apple platforms, right? Everybody is worried about installing the latest OS in October because, oh gosh, what's it going to break if I do it?
Yep, absolutely. I would say the I'm sorry, you're putting me on the spot as far as that's a particular one that I've seen in the real world. I'm blanking at the moment, but and I will mention another thing that we noticed from the observations with talking with the projects, which was, as Alyssa had already mentioned, we did see lots of issues with dependencies. I mean, dependencies are hard. This one I can more comment on from another hat that I wear as part of my role at NCSA is managing some web-based Python applications, and dependencies are hard. Vetting dependencies before they're added ahead of time to make sure that they're being actively maintained, keeping up on them to update our own code, keeping up on the libraries to make sure that they continue to be maintained. All of that's just hard. And we heard projects are struggling with these despite using some of the active dependency tools that I think are going to be talked about more. So that's a challenge and will continue to be a challenge.
Right, Sean, may I add something here?
Yes, please, Alyssa.
As for continuing on the tools arena, even though it's great seeing project using the tool for checking dependencies, it will be even better if groups use more than just one tool. Because despite what vendors tell you and try to sell you, it's not that a single tool will find all the problems. And that applies for tools for dependency checks and for automatic assessment for finding vulnerabilities in the code. So one thing to improve is having the groups using different tools on their code base, right? Different tools will report a different set of issues. That will be important. And if you allow me to connect that with testing, it will be also something to improve will be for groups, not only testing for security, but using techniques like fuzz testing and penetration testing. And even if they had more resources, perform activities like an in-depth vulnerability assessment. And always having a different team doing the testing and doing the security assessment, because otherwise, the same developers are biased as for their own code.
So Alyssa, before I move on to Andrew, let me just apologize in advance for putting you on the spot as well.
No problem.
And just ask, you've mentioned fuzz testing, vulnerability assessment, some of these other sorts of things. And so I'm first going to give a preview of your training session on Friday with Bart Miller. And so this is an excellent place to learn more about that. But at the same time, I can imagine members of the audience saying, wow, fuzz testing and all these other sorts of things. I'm just trying to write code to do something for my scientific data analysis. What is this going to do to me? What does that involve? Can you just maybe give 2 or 3 sentences on when you describe this, to give people a sense in terms of how this is going to change their lives or not, as the case may be?
Yeah, I mean, here is the situation is that like the urgent things don't give you time for the important things. Right, and that means, okay, I'm going to put my efforts on what the next release needs instead of and the security things. Okay, I know they are important, but I just really don't have time right now. That's that's sad but common mindset. But yeah, by using fuzz testing, fuzz testing can give you issues. I mean, actually bugs, and some of those bugs could be security related that your program has. And there are tools for doing that, and there are very well-known techniques. So really, there is no good excuse for not doing that. And as for vulnerability assessment, right, yeah, I mean, you need more resources, and that means more personnel and time, and that's end up costing money. But you can use tools, and tools will catch some of the security issues your code have. And a very good kind of advice is to use tools since the day one of your development. Obviously, if you already have a code base, okay, better late than never. But the effort will be a bit less traumatic if you use tools from day one.
Super, Alyssa, thank you. So I think that maybe just to summarize, the short answer is don't be afraid. There's tools to help automate this. That's what computers are for. And so let's use them. And so that way it's not actually going to reduce the quality of your life to do fuzz testing on your code.
And we are, and there is also Astra CI. You can use us as a resource, of course.
Great, super, thank you. And again, a shout out to Alyssa and Bart's training on Friday. Andrew, let me toss this to you. What are some of the things you thought software projects should focus on doing better?
Yeah, actually, I saw 3 things just that came out of evidence-based out of the interviews. But first and foremost, basically projects need to create and assign the role of a security lead or a point of contact, something similar to a CISO for cyber infrastructure. This person's responsibilities would include identifying vulnerabilities to dependent/third-party libraries, building and managing conduits to announce vulnerabilities in the organization's own product, ensuring that staff receive training in secure code development. They would also actively seek external security help where necessary. For example, tapping the institution's centralized IT in order to leverage tools, audits, reviews. And perhaps most importantly, they must keep leadership appraised of the project's current security posture. That last responsibility carries into another task that they should be doing, and that is without well-connected leadership, programmers can easily get overwhelmed in both trying to do too much, which can lead to poor design or coding, or in getting lost trying to find help. With leadership, project management can be leveraged to aid developers, setting realistic goals and keeping on task. Leadership will also provide other forms of support. For example, resource procurement that will enable programmers to achieve the project's desired goals. Lastly, projects can't be closed-minded when it comes to security. We've seen the culture of go it alone. That is, we don't need to adopt any external security frameworks, control sets, etc., because we've had success in the past without them. But that culture can only work if the project is abreast of the current threat landscape. And additionally, they have to have the resources necessary to address mitigating those threats. But I guess the bigger point here is that you don't need to go it alone.
Super, thanks, Andrew. So this is a bit of an oversimplification, but I think I'm going to summarize the comments from everyone here as engineering to a certain extent. Kay talked about engineering in the sense that we're separating feature releases from security releases. It's in the same way, the separating, redoing your foundation of your house or fixing the dry rot should be, separate from choosing the sconces that you put on your wall, right? And these are separate things that are separate decisions and need to happen at separate times. Alyssa talked about using computers as computers. Computers are good at automating complex tasks, so let's use them for that. It doesn't have to be super hard, and if you can attend Alyssa's half-day training once every couple of years, then you might be in good shape for doing this in your organization. And Andrew, I heard you talk a lot about organizational engineering as well. Who's in charge? This even happened in our annual challenge, right? If we assign something to more than one person, that means we assigned it to no one. The buck stops at one single person, and that person needs to know what they're doing and take responsibility for overseeing the entire organization or the various elements of the organization as well. And of course, engineering outside the organization as well, knowing how to reach out. And thanks for pointing out Trusted CI's role in that as well. Let me just briefly toss this out. We've only got less than 10 minutes left, and so we're probably only going to get through one other question here, but let me toss it out to the audience. What are some other things that you think that our team has not described that you think that scientific software developers can reasonably do, right? We're not suggesting people start writing code in temporal logic and doing a formal verification on it. This is the reasonable kinds of approaches that one can do in scientific software development. And I'll leave the chat open for that. Maybe we'll
yeah, Sean,
while, oh yeah, Alyssa,
while waiting for comments or questions from the attendees, one important point that I haven't mentioned today is actually training, because I mean we were paying attention to what the groups we were working with were doing training wise, and training was very informal, and people really didn't have a background in security, and they were learning about security as they went through the project. And but at the same time, and it might be a bit contradictory, but people are aware of the need of training, but they don't really know exactly where to go to get the training they need. And that's another field where we as Trusted CI try to help and contribute. And here I encourage people who's interested in attending our tutorial on Friday on secure programming for the web and automated assessment tools.
thanks so much, Alyssa. So next question for the audience. Trusted CI, as a couple of folks have pointed out in the last question, is here to help the community. And this is our primary mission, our only real mission. And so what are some of the things that you think Trusted CI you can do to best help the community make these improvements going forward? And why don't I kick this back off with Andrew again?
Sure. I couldn't have had a better lead-in than Scott Russell's talk earlier today, but Trusted CI just released the first framework implementation guide, or FIG, for research cyber infrastructure operators this year. And although this initial FIG is not tailored for secure software design, several of the frameworks must, especially in the governance and mission pillars, are applicable to research software development. And thus the FIG, as Scott said, should prove to be a useful tool for not only research cyber infrastructure operators, but software development as well.
Thank you, Andrew. That's fantastic. And yeah, what a heroic effort the framework is. And I'm really looking forward to seeing its continued adoption as we go forward into the next year. Going out of order again, maybe Kay, what are some of your thoughts on, again, how trusted CI can be helping the community with respect to secure software development?
So to go on a very brief tangent here, some of the interesting discussions that we've had as part of this project are trying to pin down exactly what makes software written for scientific projects, what makes their security needs different from general software security needs. And there's some things that we can sort of say, painting with a broad brush, that tend to be common to scientific software, is that often it's written by people who maybe don't have a background in software development, although again, that's not always true, or might tend to be written by transient staff, who someone coming in as a graduate student who's writing for a little bit and then maybe is moving on to something else. Of course, that's not true again for everything, but one of the interesting things, though, that's also true is a lot of the needs are the same, is that there are some basic principles of sort of secure software development that would help scientific projects just as much as they would help other projects. And one of the things we heard when we were asking about training to the interviewees is that they were just struggling to know what training was appropriate for them. Is that there's such a plethora of training out there, but it's not necessarily written in a language that they can understand, or having trouble evaluating it. And so one of the things I think Trusted CI can do, beyond providing excellent training that we develop ourselves, is to point out to some of these projects, we know it's overwhelming, but here are the resources that we've vetted and that we can recommend. Here is good training on how to do things properly, as far as code storage, as far as management process, as far as tools, anything like that. And of course, that we're, as Sean's mentioned multiple times, so we'll be working on producing our own software assurance guide that will provide some of these, some information, some guidance, as well as some pointers to other training later this year.
Thanks, Kay. Those are some really interesting points. Really, where else other than software development of some of these really large projects do you have such complexity associated with the engineering of these human-built systems? There's so many other things that we build in the world, but the level of complexity, the fact that there's no laws of physics to guide these sorts of things, and yet, as you point out, that we're giving this to graduate students in summer projects, and some of these things end up running scientific instruments, and so the combination of the complexity and the multiple curveballs that we throw to that level of complexity in the academic and scientific software communities makes this really hard. There's a better word for it, but a question from the community.
Yeah,
Go ahead. Hang on just a second, Alyssa.
No, I was going to say there is a question, and probably you.
Yeah, what if a new crypto stack, think quantum proof, were required? Can you suggest a path for quality assurance? Yeah, so that's actually a great lead into the next question, which is what are the things that you might come up in software development going forward? So this is kind of where, what are the curveballs we might see? We've got about 2 minutes left in our panel here. So would somebody on the panel like to take this question? Alyssa, do you want to take that one?
Well, I will say, don't do it by yourself and leave it to the experts, right? Because for example, crypto algorithm used that we use currently, they have been kind of tested and retested, and from time to time, an algorithm is broken, right? But the thing, there are, people whose whole life is that realm. So leave that task to them.
Yeah, no, that's great, Alyssa. I think just to address the question from the audience a little bit more, I think that in science, we aren't going to be the first to need to adopt this. It's going to be a bank or Google or someone like that. And so almost certainly high quality open source libraries will be available that will be relatively easy to drop in. Andrew, did you want to put a punctuation on that?
That was exactly what I was just going to say. It was actually, something I was going to address as what are the issues that are going to come up. And I can tell you right now, one of the main issues is going to be compliance, right? This has been hitting programmers for a while. It can be nigh intractable, right? Being required to code in a specific language or having to deprecate in place protocols for a new security protocol. But we just have to be patient, I guess is the term, and wait for these, open source solutions. And not only that, but also the linting and the other, CI/CD tools that we're using and checks for the code we have to wait for them to be developed for this. Yeah.
Thank you, Andrew. We are at time. I'd like to thank the panel, Kay, Andrew, and Alyssa. I'd like to thank the entire annual challenge team, also including Mark, Jason, and Bart. I'd like to thank all of our organizations that have provided us insight and wisdom as we produce this. Look forward to our guide later this year, and thanks to the audience for listening and asking questions.
Thank you all. We're letting go for a break now. You have about 15 minutes.